Okay, what we're going to do is I'm going to show you how to do talking to the text. How many of you are familiar with talking to the text? If you have Mr. Paul, probably you are.
Stop talking.
So, this is what we're going to do. You have to read pages 477 and 478, okay? On those two pages, you will be required to come up with, out of both those pages, one prediction, two comments over those two pages, two questions that you may have when you read those two pages, one conclusion after you've read those two pages. And you need to try all the guided practice problems. So I'm going to give you an example of things. This might be how someone might do this. Why are we doing this? Because you need to learn how to dissect and understand math books, science books, things like that. So this is 476. So I might look at this and say, all right, I might make a prediction. Exponential growth. How does a catfish weight change as it grows? One of my prediction might be, this book is going to tell me a formula for how to figure out how big something gets. So for a prediction, I might put here, prediction. My prediction might be, I'm going to find out. Are we supposed to? Nope. I am going to find out how things or numbers grow. That's my prediction. Okay, I may or may not find that out. Just like science. Science, its prediction is not right or wrong. Now I'm going to continue to read this and see if I have any questions or comments as I go along. Okay, in lesson 8.3, you learned about exponential functions. One use all exponential functions is to model exponential growth. In example 1, you will look at the weight of a newly hatched catfish when that weight is increased by 10% each week, I think. Can I see your book real quick? So, on the first one, a quantity is growing exponentially if it increases by the same percent r in each unit of time. This is called exponential growth. So one comment I may have is, I'm going to label it with a C. One comment I may have is R stands for what? 4%. So that's just a comment to myself. That's just something I was thinking of. Let's see, where C is the initial amount and R is the growth rate. T represents time, and both C and R are positive. It's called the growth factor. My question might be, I'm confused. I don't understand really what growth factor is right now. So what exactly is growth factor? I'm still confused. What is growth factor? Because after reading that, I still don't know. So that's one of my questions. All right, then if we scroll down a little bit, we are going to do, here's an example. Is this the example we're going to do? No, okay. So here, a newly hatched channel catfish typically weighs 0.06 grams during the first 6 weeks of life. Its weight increases by about 10% each day. Write a model for the weight of the catfish during the first 6 weeks. So my comment might be, as I read this, so I have to plug out, my comment might be, I plug the numbers into the formula, and I will see how big the catfish is getting. So far, I have 2 comments. That's what I need to have. One prediction. I have one question, so I need to have the question and conclusion all over the 2 pages. Okay, I'm just doing 1 page right now, but you have 2 pages to do it. I do have to check all, when it says checkpoint, you have to try the problem. So let's try it. A TV station, local news program has 50,000 viewers. The managers of the station hope to increase the number of viewers by 2% each month. Write an exponential growth model to represent the number of viewers in T months. So, on your paper, you might write A is my initial amount. I know that. So what is my initial amount? I'm looking at the problem. Oh, we start off with 50,000 viewers. So A equals 50,000. My B stands for my rate or my percent. I know that from yesterday's notes. So I'm going to plug in 2%, which is 0.02 as a decimal. Now, if I choose to use the AB to the X model, what do I have to add to this 0.02? A 1. So really it's going to be 1.02. Now I have T for the time. And we just know that it's going to be to the, let's see, in T months. We don't know. So it's just going to be to the, in months. We don't know what it is. So now it says I have to write a model. I'm choosing to do the y equals AB to the x. Y equals AB to the x power. I just simply have to plug in my numbers. Y equals A is 50,000 times my B, which is 1.02, to the x power. We don't know what it is right now. That's why it just has to remain x. If it says 6 months, we put in 6. If it says 5 months, we put in 5. Okay? All right, and I'm going to say, I don't know, maybe my question, obviously you have another page to go before you can finish your questions. Another question I may have is, oh, I wonder how many viewers would be in 6 months. That would be a question of mine. How many viewers would there be in 6 months? Let's say I finished reading both those 2 pages that you have to read. I might conclude, my conclusion might be that for an exponential growth model, the number's always going to get larger. My answer is always going to get larger, my numbers. So that might be my conclusion. In an exponential growth model, answer will be bigger than the initial amount, or the starting amount, whatever. I'm going to put the starting point. That's what you have to do. You have 2 pages to get a prediction, 2 questions, 2 comments, and a conclusion. For every 2 pages you read, you have to get that. You have to try all your problems. When it says checkpoint, you got to try it. Are there any questions? So your first 2 pages, you have to look at 477 and 478 and come up with 1 prediction, 2 comments, 2 questions, and a conclusion. Then, when you get that done, you have to go to 483 and 484. Read those 2 pages and come up with the same thing. 1 prediction from those 2 pages, 2 comments, 2 questions, and a conclusion. You have to try every checkpoint problem. Are there any questions? Yes? Jesse, I can't hear you.
No, the checkpoints are due at the end of the hour. The review is due tomorrow when you come into class.
The checkpoints are part of what you're doing.
We're going to do predictions, comments, questions, conclusions, and checkpoints. You have to have 1 prediction, 2 comments, 2 questions, 1 conclusion. All the checkpoints per every 2 pages.